hearing my voice? Okay, good. Sorry for the delay. I was ready to start. Hear my voice? Good. So, see my screen also. We're gonna start our lecture. Today's gonna be about probability. So let's start with the definition. We'll talk first about the definition of the sample space. Next, we will define what we call the event. Talk about the counting of sample points and probability of an event, additive rule, then the conditional probability independence and the product rule. The last thing we'll talk about the Bayes rule. We're not gonna cover everything today. We will cover 2, 2, 2, 2, 3, and the rest inshallah we will cover once we finish that. Chapter 1 and chapter 2 are the parts that are gonna be MTA exam inshallah. So that we have the first thing we're gonna talk about is what we call the sample space. Now when we are doing any statistical experiment here, when we are doing any statistical study, outcomes that you have in your experiment. So the set of outcomes is our sample space. We refer to capital letter S here. For example, if we have the experiment of rolling one die, the outcomes are 1, 2, 3, 11, and 6. And if we are considering the output, the sample space will consist of 2 parts, even and odd. Here, let me show you this in details in the following example. I'm talking about one coin. If you have a one coin, you are flipping this coin, the outcomes will be a head or a tail. So the sample space, the set of outcomes, is head and new element. Head or tail. We refer to them with H and T. If I'm talking about flipping 2 coins, not just one, first coin will give me the outcomes head, and the flipping will give me again a head and tail. If I get a head in the first time, and I will get tail in the first time. So the outcomes are head, head, head and tail, tail and head, and tail and tail. So how many outcomes we have here? We have 4 outcomes. So 1 to 4 outcomes in my sample space. This is the case of flipping 2 coins. Well, if we call tossing a die, you can see here. You saw this example in the first slide. Now here I'm gonna talk about it in detail. And now the die is a square with spaces, numbers from 1 to 6. Each time you toss the die, you expect getting a number from 1 to 6. So I say that my sample space, my set of 3. Okay, so in the experiment of tossing the die, I expect getting numbers from 1 to 6. Okay. Now, what if I'm choosing 2 dice here? Okay. Again, we can use the 3. Two. That's correct. 36 outcomes we have. Excellent. 4, 5, and 6. In the second toss, each of one outcomes again will 1, 2, 5, 6. Each outcomes. So 6 outcomes in the first time. Multiply 6 outcomes. One of the outcomes here again will have Well, let me know if you hear my voice well, please. Hello? The voice good. The problem from Nisreen, the problem from your side, maybe just look out and in again, please. Look out and in again. Problem from my side, I think it's from your side then. Look out and in again, please. Now the next example, I'm talking about again the sample space, but for being cars. You know this. So if you cannot hear, look out again. Get the problem from your side. So in the blink are black, the spades and the clubs, and two of them are the diamonds. One set we have 13 cars. So in total, since I have a 13 cars, 13 multiply the 4 set that we have, so 52 outcomes here in this experiment. So in withdrawing one big card set, the set of outcomes 52. Is that clear? Now this table here, I am in a factory, they have an items in a box, for example. They are selecting randomly one item, writing defective if this item is defective, and they are writing N for non-defective items. So I'm choosing the 3 items, so I'm doing this price times here. So the 3 representation for this experiment, as you can see here, the first item gonna be defective or non-defective, and I'm gonna be an N. And the second time when I choose the item again, it's gonna be defective or non-defective. If the first defective, second one will be defective. In the third item, I will have again defective and non-defective. Now, two outcomes in the second time, and 2 outcomes in the third time. So the result is 8 outcomes in my sample space. As you can see from that space will be defective, 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 or DDN, or DND, or DNN, or the second NND, and so on with the options. How many of them we have? We have 8 outcomes. So this is my sample space experiment. Okay, is that clear here? Those are the 8 that you can see. Defective, defective, non-defective. We can write them here like S, my sample C, D, D. Defective, defective, and non-defective. Or defective, non-defective, and defective again. Defective, non-defective, non-defective, and until we write outcome. Now it's okay. Okay, great. Now we know what does the sample space mean. We define the sample space. Our next is finding what we call the event. So first we define what we call the sample space. S. The event here defined to be subset of the sample space. If this is your sample space F, the event is a part of your sample space. Now, if I'm talking of rolling the die that we talked about, the outcomes are 1, 2, 3, 4, 5, and 6. Event from my mind, just an event E1 that you are getting the number 1. It's a part of from all the outcomes that we have in our sample space. So this is an event. The event 2 is that the out number. So the outcomes are 2, 4, and 6 in this example. If I say my event is getting an odd number here, so getting an odd number like having 1, 3, and 5. Okay, so for E4, get number less than 4. What will I have? 4 is getting a number less than 4. What do you think? I will have this an event. With the letter E, as you can see. Okay, this is event. We refer to it with the letter E, with the letter A, with the letter B, whatever. Okay. Now we know what does the event mean. We talk about the complement of an event. The complement يعني المكملة. Now this is my sample. An event A. The complement of A or A is anything that is in S but not in my A. In S but not in my A is the complement of A that completes A, I mean. Okay. In this example here, R is the event that a red card, when we talk about ordinary deck here, we said that we have 4 bars, 13 here, and 13, and 13. Some are the red. The second part is the black event that we are getting a red card out of the 52 playing cards that we have, and S is the entire deck. Okay, so this is my S, the 52. What would R is getting the red? What is the complement? What do you think? What completes the red? Getting the black. Is that right? Correct. Red is getting a black. So this is the complement of event getting a red. For example, let me give you a simpler example. If I'm talking about tossing the die here, I do 5. And 6, and my even, an even number 2, 6. What will be my A complement? What's here? Number that are 1, 3, and 5. The odd numbers. That's correct. So this is the complement of an event. In this example, we have the sample space that has the items, book, cell phone, in between. Paper, stationery, and the laptop. My event A is a book, stationery, and laptop, and a paper. What will be the A here? Anything that is not an A, yani the cell phone and the MP3. Clear? Okay. Is it clear now? So the next thing is the intersection of events. Now again, let me show you the figure. Talking about this square rectangle represents the S, and inside it I have the event A, and the other side here I have another event, which is the event B, which is event A and B, where referred with this sample A, 6B are all the items or all the points that are shared between A and B, all the points that are common A and B. Okay. For example, look at this example with me. We have an example of the event A is getting 2, 4, and 6. The event B is getting 4, 5, and 6. A and B, the sharing, the common points are 4 and 6. So the intersection is the points in common, the 4 and 6. That's correct. Now this in here, I have E is the event that the person that I selected randomly from a classroom is I, okay, and F is another event that this person is event that this student is an ITC. F that is a student. What will be the intersection? What will be the intersection of E intersect F? It will be that the student is the female student. It's a student, a female student in the ITC department. Let's study ITC. If I'm saying the intersection, the common female that study ITC. So A intersect F, study ITC. You can see them. Clear? Any question? So now let's go to define what we call this case. In the special case, when you have two events A and B with nothing in common between them, yani this is my S, this is my A, this is my B, I couldn't find anything in common in between them. In this case, I say that the two events are disjoint or mutually exclusive. We say they are mutually exclusive, or usually we are saying disjoint events. Okay, منفصلة, they have nothing in common. How we are writing this mathematically? We write it like A intersect B is equal to phi. Phi is the empty set, or other way to write it is by writing two empty brackets like this. Two curvy brackets with nothing in between them. So A intersect B equal to phi give me that two events here are disjoint, and this is a very important special case. You will see later a lot. Okay, here we have the following example. In the English letters, the set of vowels, the vowels in English language, the A, E, I, O, and U. Now the consonants that we have like L, R, S, and T, and other letters that are not vowels, you will see that their intersection is equal, nothing in common in between them. Okay, so we can say that they cannot happen at the same time, they are disjoint, or they are mutually exclusive here. Okay. The third operation that we will do on events is what we call the union. The union يعني الاتحاد. So say we have an event A, we have this is my S. The union is everything that is in A and in B at the same time, and this is all the elements that we have A and B طبعا بالضبط. And this is how we are writing it. This is the sample that we are using for the union. This is A union the B. Okay. That's correct. Similar to the letter U, capital U ده. Okay. اتحاد يعني نجمعهم مع بعض، هذا معنى كلمة اتحاد. اليونيون اللي في الA واللي في لا مش العناصر المشتركة. العناصر المشتركة اللي هي الانترسكشن. الاتحاد كل شيء everything العناصر بالضبط، بس بدون تكرار لأنه we are talking about a set طبعا بدون تكرار. That's right. We will see in this example here المشتركة وغير المشتركة. صحيح everything. You can see the shaded area here. حتى المشتركة. But we are not repeating. The one in the middle, no need to write them 2 times. You write them just 1 time. Okay? Well, you'll see in the example. Just wait a minute and you'll see the example. بالضبط. In the example of ditossing, كنت M131 بس في M131 كنا نتكلم عن الست، عن المجموعات. Now in the probability I'm talking about the sets that are event in the sample space or in the event. Okay, this is a special case of what one. It's a special case of that. So in a ditossing experiment, my event A is the set to the event B is are the elements 4, 5, and 6. We might be interested in either A or B occurring, or both A, B, or both of them happen. This is the union. So A union B, all the elements, يعني 2, 4, 5 and 6. Notice that the 4 had here, but we just write it 1 time here, and the 6 happened 2 times, so but we just write it 1 time. No need to repeat the elements when you are writing a set. Yeah. So here in this example, can you see this is the Venn diagram? If you took the course in 131, you will remember that this is the Venn diagram. This is the representation of the set. The full square here, the rectangle, represents the whole set, which is the sample space اللي هو كنا ناخذ نسميه domain or universe of this course. And inside it we have 3 sets, A, B, and C. Can you see? And the points here show me the elements, all the sets that we have. And now A union C, what's A union C? By just looking here, it's 1, 2, 3, 4, 5, and 7. Is that clear to you? And what about B intersect A? You must know those symbols. You must know how to read them, huh? B intersect A means the common elements between B and A. What's common between B and A? We have it's 1 and 2. So in between B and A I have 1 and 2. Now A intersect B intersect C يعني means the common between the 3 of them. What's common between the 3 of them? The 1. That's correct. But what if I said here they want A union B, after you find the union intersect the C. So A union B is this area that I'm shading here, huh? This is A union B. Intersect C, and here's my intersection of A union B union. Intersect C is 1, 3, and 4. Yeah, that's correct. Good. So this is the A union B intersect the C here. Clear? Good. Next, here again we have the Venn diagram, and they are just showing me some A, some B, some C inside it. They are saying that A, B, and C are all subsets. صح ولا لا? All of them are a part of S. I know that. B is a subset from A. What does subset mean? يعني مجموعة جزئية, يعني totally included inside. You can see here from the diagram. All B is inside A. صح ولا لا? Totally B is included inside the A. And also you have that B intersect C is equal to what? What's B intersect C? Do I have any intersection between B and C? Nothing, صح? So B intersect C is مش زيرو, نقول 5. B intersect C يعني nothing. B and C are disjoint أو mutually exclusive, منفصلين تماما, صح ولا لا? So mutually say disjoint. And here say have at least one element, صح? لأن I have a part between joints. A union B. A includes the B. The B is B. What's the intersection between A and B? Yeah, the intersection not the same. It is B. لأن all the B inside the A, so the intersection is B. Correct. Now in your book you will find some important relations for the set. Let me write them for you. A intersect phi. What do you think? A intersect phi. If you intersect A with a phi, it is the phi, correct. طيب if A union the phi, it's the A, correct. طيب if A union the complement of A, ايش رايكم؟ احنا عندنا الاس, صح؟ the A برا ال A I have complement. طيب اتحاد او reunion ال A مع ال A complement is what? the whole S, صح. طيب if I intersect A with its complement, what do you think? It's nothing, it's the phi. What is its complement? What's the complement of S? It's phi, صح. And what's the complement of phi? It's S, صح ولا لا؟ اللي يكمل الفاي is S. What is the complement of the complement? It's A. We go back to the A as if they cancel each other. Also we have what we call the De Morgan's law. عندنا ال A intersect B dash is complement A, union complement to B. The intersection changed to union, and we have that A union the B dash is A dash intersect B dash. هذه اللي نسميها احنا De Morgan law. Also if you took the course M131 you would know those relations. Okay, you can find them in the book. They are not in the slide, they are in the book. They are useful actually. You'll see later that we will use some of them. Any questions till now? Any questions, students? Okay, good. Now we move to the next slide that we talk about the multiplication rule. Actually, we applied this multiplication rule before. When you have a coin, we have a head and tail, and the second time we will have a head and tail. The first time I'm flipping, I get the tail option. The second time when I'm flipping a coin, I have two options also. So 2 multiplied 2 equal to 4. So I have 4 outcomes in my sample space. This is what multiplication rule says. If operation can be performed in one way and is for each of one this way, a second operation can be performed by in 2 ways, then the 2 operations together can be performed in 2 ways. This is what we have here. Also, when we remember when we do the tossing the die, we have 1, 2, 3, 4, 5, and 6, and again we will have 6 outcomes from each one of those. So we have 6 multiply 6, we have 30. Do you remember? So this is what we call the multiplication rule. Example: how many sample points are there in a sample when a pair of die on? A pair of die, we say we have a 6 times first and a 6 times in the second time, so it is a 36. It's clear now? Correct. Let's have this example. We have a developer that developing and they are offering homes for a buyer, and the choices of the houses has 2 things: exterior style اللي هو التصميم الخارجي للهاوس، والفلور بلان يعني عدد الطوابق في البيت. Okay, so they are developing homes here, and I'm trying to see how many options does the buyer have. Okay, we have 2 ways to do the homes. First, the exterior style اللي هو الشكل الخارجي can be thunder, what is this, colonial and traditional. Okay, so 4 options for the exterior style. All of them are ranch, 2-story, or split. So for the 4 options, for the second thing, which is the floor plan, I have 3 options. So 4 to 12, so 12 options each. I have to choose between those homes. Is that clear? Let me enlarge the slide for you. Have a look at. I have 2 things or 2 steps to follow. Okay, between the exterior style I have, then I will choose between the type of floors that I have 4 options, followed by 3, multiply 3 using the multiple 2, 12. Okay. In this type can be thunder, rustic, colonial, or traditional style. So we have 4 options for the exterior style, followed by the number of floors in the home that we will build. Okay, the number of floors can be in the ranch way. All of those are ways to design houses. You can search the internet and get the meaning of these things. two-story or split level. Again, range, two-story, split level. Again, range, two-story, and split level. So 3 options for the second step. So 4 multiply 3 using the multiplication rule is equal to 12. Okay. This multiplication rule can be generalized to more than 2 steps. يعني if I'm doing 4 things, يعني I'm flipping the coin 3 times. 4 times. Again, we can generalize this multiplication rule. Operation 2 can be done in 2 ways, in 3 ways. In 4 till we reach in k, then in 1 in k times that we have. Okay, we have the following example. Let me enlarge it here. Sam is going to assemble a car by himself. He has choices of shop, so he has 2 brands his jobs from, and he has a hardware from where? From brand. So 2 multiply 4. The memory he can choose from 3. So multiply with 3. And accessory bundle from 5 local stores. So multiply 5. In how many ways can Sam order parts? Then it is 2 multiply 4 multiply 5. So he has a 120 ways to choose the parts of his computer. Okay. This is the multiplication rule. You do the operation 1, operation 2 in 2, operation 3 in 3. So then you multiply everything to get the overall or the total of the ways that you have. Hearing my voice clear? Any question here? Okay, good. Sorry for the delay. I was any question? Ready to start. Hear my voice? Good. Okay, good. So see my screen also. We're gonna start our lecture. Today's gonna be about probability. So let's start with the definition. We'll talk first about the definition of the sample space. Next we will have the following. Suppose that a computer assistant talk about the
multiple choice question now. We have a computer test that has 5 rules,
then the conditional probability independence.
So I have 5 questions.
The last thing we'll talk about the base rule. We're not gonna cover everything today. We will cover 2, 1, 2, 2, 2, 3.
5 questions
and the rest,
we have.
Inshallah, we will cover.
The compute comparable question for the 5 options for the first question.
1 and chapter 2 are the bars that are gonna be
for the second question, and 6 for the fourth, and 10 for the fifth. How many different 5 question tests?
We are doing any statistical experiment
the computer
select.
So I have 5 question options for each one question. Of course, it is a multiple 5 multiply 8
outcomes that you have
multiply 6 multiply 5 so multiply the result here. You will get it. It is 12,000
ways. We have different ways to do. For example,
the questions
if we have the experiment of rolling the 1 die, the outcomes are.
Let's see example here. How many 4 number larger than 7,000 can be formed?
Considering the sample space will consist of 2 parts, even and odd.
From the digits 5, 6, 7, 8, and 9 without
example. I'm talking about 1 coin. If you have a 1 coin, you are
repetition, يعني without repeating the things. Now pay attention to this question very well, because
so the symbol space, the set of outcomes is head and new elements. head or tail. We refer to them with H and
Usually there must be a question similar to this.
Talking about flipping two coins, not just one. First coin will give me the outcomes head, and the flipping will give me again a head and tail if I get a head in the first time, and I will get tail in the first time. So the outcomes are head, head, head and tail, tail and head, and tail and tail. So how many outcomes we have here? We have 4
in the example. I'm talking about
my sample space. This is the case of flipping 2 coins. Well, if we call tossing a die, you can see here. So this is
4-digit number. So I have a number.
Talk about it in detail. And now the die is a square with faces, numbers
with
from 1 to 6.
4
Each
blazes.
time you just
It's a 4-digit. Okay. It should be larger than 7,000. يعني 7,000, 8,000 or 9,000. I'm choosing my digits from 5, 6, 7, 8 and 9. Okay. So for the first place, the number is larger than 1,000. I can between 7, 8 and 9. So I have only 3 options for the first place. Okay. Only 3 options. Losing with 6, 7, 8, 9. And I want the greater than 7. So it be something. Or can be 9. It cannot be 5,000 or 6,000. So the first place, I have only 3 numbers to choose in between. If I choose my first number, I cannot repeat it because they say no repetitions allowed. So I choose my first number. What if I choose and I have 1, 2, 3, 4, 5 numbers already? Already I have 5 numbers here. I have numbers. I order them in the so the I have all options here. Then I already choose a 1, 3 options. So I remain here. Multiplication rule, everything will free for 22 different brackets. Okay? Do you have any comments? Well, let me know if you hear my voice well, please. So, the voice good. See the problem from. Any questions, students? Misreen, the problem from your side. Just look out and in again, please. Out and in again. Hello? Problem from my side. I think it's from your side. Look out and in again, please. My voice. Now the next example, now you can hear my voice. Now you gain the sample space, but for being cast. Now is my voice clear now? So if you cannot hear me, read out again. Now you can hear my voice. So in the blink are black, the spades and the clubs. And 2 of them are the diamonds. The 2 examples, my voice. We have 13 cars. So in total, since I have a 13 cars, 30 multiply the 4 that we have, so 52 outcomes here in this experiment. So now withdrawing 1 big card, the set of outcomes 52. Is that clear? Now this table here, I am in a factory, they have an item in a box, for example. They are selecting randomly one item, writing defective if this item is defective, and they are writing N for non-defective items. So I'm choosing the 3 items, so I'm doing this plus times here. So the 3 representation for this experiment, as you can see here, the first item gonna be defective or non-defective, and I'm gonna do and n. And the second time when I choose the item again, it's gonna be defective or non-defective. If the first and second one will be defective, in the third item I will have again defective and non-defective. Now two outcomes in the second time and 2 outcomes in the third time. So the result is 8 outcomes in my sample space. As you can see from the space will be defective, 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 or DDN, or DND, or DNN, or the second NND, and so on with the options. How many of them we have?
Okay,
We have 8 outcomes. So this is my sample space experiment. Okay, is that clear here?
okay, good. Let's go back to this example. We was here, I think.
Those are the 8 that you can see. Defective, defective, non-defective. We can write them here.
So
like
let's go back.
My sample CDD. Defective, defective, and non-defective.
So example, we have
Or defective, non-defective, and defective again. Defective,
computer assisted test. I have a test.
Okay.
In this test, I have a question, 5 places to fill here. The computer stores
Now
5.
we know what does the sample space mean. We define the sample space.
Variable question for the first options here. 8 second, and 6 for the third, 5 for the fourth, and
So
10 the fifth. How many different 5 question tests can the computers
even
do?
here,
One or more questions. So
defined to be subset of the sample space.
we
If
have
this is
the
your
multiplication
sample space
rule
F,
in this
the
time. We
event
by
is
5
part of
multiply
your
8
sample space.
multiply. The
Now,
result
I'm
is
not throwing the die that we
12,012.
about. The outcomes are 1, 2, 3, 4, 5, and 6. Event from my mind, just an event E1 that you are getting the number
Do this one.
It's a part of all,
It's fine, I'm gonna repeat it.
from
It's
all
fine.
the outcomes that we
Just
have
let's
in
finish
our
this
sample
one, huh?
space.
I got
So
it now.
this is an event. The event Q
How
is that
many
the out number.
4-digit numbers
So the
now
outcomes are
larger
2, 4,
than
and 6 in this example. If I
7,000
say my
can be
event
formed from the
is getting
digits
an
5,
odd
6, 7,
number here.
and 8,
So
and
getting an
9.
odd number
Pay
like
attention
having 1, 3,
to
and
this
5.
one. I want
So
4-digit
for
numbers,
four
and without repetition, يعني we
with
cannot beat the numbers
number
that we choose. With the digits 6, 7, 8, and 9.
than 4. What will I have? 4 is
And my
getting a number
choice
with
should be a number greater than 7.
from
I'm
4.
talking
What
about
do you
this number, so
I will
4
have
places
two.
fell
This is
here.
even.
ماشي? My number should be greater than 7,000. Greater than 7,000, يعني it could be 7 something, 8,000 or 9,000. It cannot be 5 or 6,000. How many choices I have for the first place? I have 3 choices.
We refer to it with the letter E, with the letter A, with the letter B, whatever. Okay?
Yes. One here, I have already 1, 2, 3, 4, 5 choices. صح ولا لا? I have 5 queens. One of them in the first place, you remain with 4 choices for the second. For the third place, once you choose one of them, you remain with 3 choices. For the fourth place, you remain with 2 choices. Now the multiplication rule said multiply everything, multiply 3, multiply 2 to 72 different ways.
In S but not in my A.
We have to form those 4-digit numbers that we have.
The complement of A that completes A, I mean.
Is that clear?
Okay. In this example here, R is the event that a red card, when we talk about ordinary,
Depends on the options, depends on how options I have here. Let me show you a simple
that
example.
we have 4
Let
bars,
13 here, and
I'll show you
13
another example.
and 13.
Okay.
Some are the red. The second part is the black.
Depends on what they are writing. They should write for you. You will see an example. Don't worry. When repetition is allowed. If repetition is allowed, it's fine to repeat the number. Let me give
so this is my S, the 52. What would R is getting the red, or what
digit?
What is the complement? What do you think?
What
complete the red? Getting the black
from the numbers 1, 2, 3,
5. Correct. In A is getting a black. So this is the complement of event getting
repetition.
For example, let me give you a simpler example.
Allowed.
If I'm talking about tossing the die here, I choose 5.
Repetition.
And 6
not
and my
allowed.
Even
If
number.
repetition is allowed, I want to form
6. What will be my A complement? What's here?
4-digit number. So I have 4. I have how many numbers? 5. So I can
use the
5.
That's good. So this is the complement
numbers I have.
Of an event.
So it is 5.
Example, we have
multiply 5.
That has the items
4 times into 3. Okay. So the result is 5 for stationery and the laptop.
My event A is the
board,
stationery and
equal
laptop and a paper. What
625.
Anything that is not an A, the cell phone.
Wait, if they are allowing me 4, not 5. I have 5 numbers to choose in between. Okay.
Is it clear now?
If repetition is not allowed, I have places numbers. The first time I have 5 options. I use a number, I cannot use it again. It will be 4. Then 3, then it will 2. Okay. Let me give you one more example here.
So the next thing is the intersection of events. Now again, let me show you the figure. Talking about this square rectangle represents the S, and inside it I have the event A,
and how?
On the other side
wait,
I have another event, which is the event B. Events A and B were referred with this symbol A, that B, or are all the items or all the points that are shared between A and B. All the points that are common
from letters
A and B.
Okay.
And for example, look at this example with me. We have an example of the event A is getting the 2, 4
adjacent
and 6. The event B is getting 4, 5 and A and B, the sharing, the common points are 4 and 6. So the intersection is the points in common. 4 and 6, that's correct. Now this here, I have E is the event that the person that I selected randomly from a classroom is okay, and F is another.
What do you
event that this person is event that this student is an ITC. F that is a student.
The M130 Lecture
what
is
will
not
be the intersection?
Sunday.
What will be intersection?
Yeah, it's in Thursday.
E intersect
You are from the M130 your lecture is in
the student
the lecture
is the female student. It's a student, a female student in the ITC department. To study ITC. If I'm saying the intersection, the common female that study ITC. So A intersect F.
Okay, check this.
Study.
How many ways we can do
ITC.
a word from the letters A, B, C, D, where Here
A repetition is not allowed.
A
يعني
question?
password we say. A password, huh? I'm not repeating the So now let's go to define what we call this case. In the special case,
here I have
when
A,
you
B, C,
have
D,
so I have
events,
four
A and B
places.
with
For
nothing
the first
in common
place I
with-
have
between
four
them.
choices.
This
The
is my
second
A,
place I have
this is
and
my
I
A, this is
have
my
choice.
B.
I
I
have
cannot,
multiply two,
couldn't
multiply
find anything in common in between
Clear
them.
now, the idea
In
is
this case, I say that the two events
for
are
you?
disjoint
Let's
or
proceed now.
mutually exclusive. We say they are mutually exclusive
multiply
or
two.
usually we are saying disjoint.
Now
events,
let's
okay?
a new topic
منفصلة.
now.
They
We will
have
talk
nothing
about
in
the
common.
permutation
How we are
and
writing this
the
mathematically? We write it like A
combination. Our
into
next
6B
thing
is
is the
equal to
permutation
5.
and
5
the
is the empty set, or other way to write it is by writing two empty brackets like this. Two curvy brackets with
Okay,
nothing
good.
in between them. So
Now
A
the
into 6B equal
permutation
to
or
5
what
give
we
me
call
that
the
the two events
MPR.
here
The
are
MPR
disjoint.
means the arrangement
And this
of
is a
all
very
or
important
part
special
of set
case.
of
You will
an
see later
object.
a lot.
Now, if
Okay?
I have
Here we have the
MPR,
following
the
example. In the English
permutation,
letters,
the
the set
permutation
of vowels. The vowels
can
in
be
English,
the
in
ways
English
we can
language,
arrange
the A, E,
in
I, O,
place.
and U. Now, the consonants that we have like L, R, S, and T, and other letters that are not vowels, you will see that their intersection is equal, nothing in common in between them. Okay? So we can say that they cannot happen at the same time. They are disjoint or they are mutually exclusive here.
To arrange them,
Okay?
I want the permutations out of those letters
The
A, B,
third
C.
operation
We
that
can
we
write
will
it
do
as A, B,
on
C,
events
A,
is
C,
what
B,
we
B,
call
A,
the
C, or
union.
B,
The
C, A,
union
or
يعني
C, B.
الاتحاد.
CAB or CBA.
So say we have an event A, we have this is my S. The union is everything that is in
6
A
ways to
and
arrange.
in
So I'm
B
talking
at
about
the
3
same
letters.
time. And this is all the elements
Doing
that
a
we
permutation
have, A
of
and
the
B
3
طبعاً.
factorial.
بالضبط. And this is how we are writing it. This is the sample
a
that we are
3
using
multiply
for the
2 multiply 1.
A
Previous
union
example,
is a B.
I have 3 letters to arrange the 3 letters in 3 places.
That's
So
correct.
it's a 3
Similar to the
multiply
letter
2
U.
multiply
Capital
1.
U.
صح ولا لا? So this is what we call a permutation of 3 things in 3 places.
Okay.
عندي 3 things I want to put them in 3 places. group ل 3
اتحاد يعني نجمعهم مع بعض. هذا معنى
one like
كلمة
the brief.
اتحاد.
Now this is the
اللي في A واللي في ال لا مش العناصر المشتركة. العناصر المشتركة اللي هي الانترسكشن. الاتحاد
factorial اللي هو المضروب and this is something you reach 3 to 1 يعني for example factorial 4
بس بدون تكرار لأنه we are talking about the set طبعا بدون
في 1
تكرار.
if I say
right.
factorial 5 it is 5 في 4 في 3
we will see in this example here.
if I
المشتركة وغير المشتركة صحيح everything you can see the shaded area here
it's 100
حتى المشتركة
في ال 9
في
ال 1
but we are not
and so on we'll calculate
the
it
one in
for you.
no need to write them 2 times you write them just 1 time. Okay.
And as a special case عندنا الفactorial is 0 the number of permutation
example just wait a minute
of an object اللي هو ال n p n برتب أشياء n من الأشياء في n من الأماكن
example
it is factorial n factorial 4 is 24 the permutation
it's M131 بس
of the letters A, B, C and D and the number of factorial 4 which is 24 which is 4 في 3
space or in the event. Okay, this is a special case of what one.
Okay,
it's a special case of that.
So you know that the NPN, the permutation of n things is factorial 1 is 1. That's correct. Now I know is NPN is equal to factorial n, and this is how we put 4 things in 4 places. عندي 4 أشياء بحطها في 4 أماكن. طيب What A or B occurring,
I
or
have
both A, B, or both
four
of them
things,
happen? This is the union. So A union
and I
B,
to put
all the elements, يعني 2, 4,
just two places. أنا عندي four things.
5
I can
and
do
6.
a
Notice
word
that
with
the 4 had here, but we just write it in one time here, and the 6 happened 2 times, so but we just write it
two
one
letters
time. No
only.
need
يعني I have four two
to
places.
repeat
So
the
four.
elements when you are writing it. Yeah.
Is four.
So here in this
Multi.
example, can you see this is the Venn diagram? If you took the course in
Multiply 2,
131,
multiply
you will
1,
remember that
like
this is the Venn diagram. This is
so
the
it is 4 multiply 3
representation of the set. The
options that we
full
have.
square here, the rectangle represents
And
the
the rule
whole
is
set
the
which is
n
the sample of
permutation
base.
on factorial n minus r. Let me write this
and
rule
inside
here.
it we have a
So
three sets,
MPR,
A, B,
when
and
I
C.
have n places, it is factorial n
And the points here show me the
divided
elements
by
of the set that we
factorial
have.
n minus
Now
the
A
r.
union C, what's A union C? By
We
just
go back to
looking
this
here,
slide with the
it's
examples
1,
that
2,
we have. In
3,
this
4,
example,
5, and 7. Is that clear to you?
example 1, we have a license plate that using
And
followed
what
by
about
3
B
digits.
intersect A?
Okay.
You must know
Three
these symbols.
letters
You must know
digit
how to
they
read
didn't
them, huh?
specify.
B
Three letters from
intersect
alphabet,
A
so I
means
have
the
26
common elements between B and A.
letters
What's
here.
common between B
Okay.
and A? We have
3 digits from 0 to 9.
It's
0
1 and
1 2 3
so
4
in
5
between
6
B
7
and A, I
8
have
9.
1
بقى
and
digit
2.
يعني رقم.
Now A intersect B intersect C يعني means the
عندي
common
the numbers
the
from
three
0
of
to
them.
9. عندي
What's common
10
between
she's
the three of them?
Okay. Different blades
one,
are
that's
possible
correct.
if
But what if I said here they
I,
want
repetition
A union
is
B,
allowed.
after you find the
Double I,
union
repetition
intersect the
allowed.
B.
For
So
I,
A union
if
B
I'm
is
allowing
this
a
area that I'm
repetition
shading
هذا
here, huh?
أتكلم
This
عن
is A
three
union
letters
B. Intersect C,
followed
and here's
by
my intersection of A union B union.
I,
Intersect C
3 digits.
is 1, 3,
صح ولا لا؟
and 4. Yeah, that's correct.
3 letters followed
Good.
by, if
So
I'm
this is the
repeating
A union
26
intersect
here,
the C here. Clear?
26 and 10 10 10. ما عندي أي إشكالية. So the result is 26 26 26 10 10 and so the answer is this if you do all the multiplication. Now there's of different now repetition
Here again
It's
we
not
have the
allowed.
Venn diagram.
The first place
and,
I will
they are
choose
just
the
showing me
Okay.
some A, some B,
the second
some C inside it.
25.
The
The third place
this
this one
A, B, and C are all subsets. صح ولا لا? All of them are a part
24.
of S. I know
multiply
that.
with
B
it is
is a subset
9
from A.
do the
What does
multiplication as you
subset
can
mean?
see
يعني
here.
مجموع
This will give you
جزئية يعني totally included inside. You can see here
answer
from the
that we
diagram. All B is inside
Is it clear?
A. صح ولا لا? Totally
that clear?
B is included inside the A. And also you have that B intersect
كيف جات لي 26 قال لي 3
Do I have
letters.
any
طيب أنا إيش
intersection between
الليترز
B
اللي
and
عندي
C?
in general؟
Nothing صح؟ So B intersect C
عندي
is
الألفابت اللي هي ال A B C 2 عندي 3 digits. They didn't specify the digits, so I have how many digits? I have 0.
مش زيرو نقول 5
1 2 3 4 لحد ال 9.
بعد يعني nothing B and C are disjoint أو mutually
الأرقام الباقية كلها جاية أساسا من ال 10 digits هذه.
منفصلين تماما.
So digits
mutually say disjoint.
Down to now.
هذه least one element صح؟ لأن I have a bar between joints.
The letters of the word drive. How many letters I have? 1 5.
A
So I want to do the arrangement.
What's the intersection between A and B?
Yeah, the 3 letters are different, so the way.
Yeah, the intersection not the same. It is B.
لأن all the B inside the A, so the intersection is B. Correct.
So it is factorial 5.
Now,
how many?
6
here. Now 6
find
digits
some
can be formed using the digits 4, 5, 6, 7, 8 and 9. How many of them
write
I have?
them
I
for
have
you.
6 numbers here.
A intersect 5.
This is that and 66,
What do you think?
which is factorial.
A intersects 5. If you intersect A with the 5. It is the 5, correct. طيب, if A union the 5.
Let's do this example.
It's the A, correct.
In 1 year,
طيب,
3
if
awards,
A union the
research,
complement
teaching,
of A.
and service. Now, one important thing I want to add for the permutation that the order
برا ال A I have طيب اتحاد أو reunion ال A مع ال A complement is what?
ايش يعني the order is important؟ يعني when I say like A B has to be A صح ولا لا؟ permutation I'm trying to change the places هنا.
It's nothing. So it's the 5. What is its complement? What's the complement of it?
Permutation. This is very important. That the order is important for the permutation.
It's 5.
And let me write it.
And what's the complement of 5?
Example here, teaching and service will be given to a class of 25 graduate students. So how many awards I have? 3 of them.
What is
the order is important now? Yes, the order is important. The prize will go to research. The second for the teaching. The third for the service. So I have 25 students, and
also
I'm choosing
we have what we
between
call
them
the
to give
Morgan's
the 3
law,
prizes. And
then A intersects B.
The order is important here.
Complement A,
okay, because the first is the
permutation.
Intersection. Again, this permutation you can find
it in the we have that A union
calculator students, huh? You can find this is
A dash. So you can find it with this
your calculator. You can get
هذه اللي نسميها احنا D.
At a 25 permutation, 3 is equal to 3.
Also, if you took the course in 131, you would know.
One more example. Now, a serial number for a product, okay, are to be made
in the book.
2 letters followed by 3
they are useful
numbers.
actually.
So
you'll see later that we will use some of them.
Follow that with
any questions till now? Any questions? Are to be taken from the first 8 letters. So I have 8 letters. Next slide, we talk about the multiplication rule. Actually, we applied this multiplication rule before. And with no repeat, and the number will order when you have and then the number to be taken from the digit. And the second time we will have a head and tail. 10 digits اللي هي من 0 the first
to 9.
time I'm flipping
so عندي 10 digits
the second time when I'm flipping the coin I have 2 options also, so 2 multiplied 2 equals
the other one, and we do
so
the
I have a 4 outcome.
So you
my
find
this is what multiplication rule says. If operation can be performed in one way, and for each of one this way, a second operation can be performed by and for the like 2 operations together can be performed in 2 ways. This is what we have here. Multiply the 2 things you remember together, when we do the tossing the die. We have 1, 2, 3, 4, 5, and 6, and again we will have a 6 outcomes from each one of those. So we have go to here that 6 multiplied.
One more example.
Do you remember? So this is what we call the multiplication.
3-letter code words are possible using
how
the first 8 letters
sample
of
are there in the sample with a pair of die on? A pair of die, we say we have a 6
of the alphabet, but I have A, B, and C. If no letter can be repeated, if I have 8, then I will use 7, then I will use 6.
Correct.
So it is
let's have this example. 3 actually. 8 to
We
7
have
to 6 to
developer
336
that developing and they are offering homes for a buyer.
Correct.
And the choices of the houses has two things: exterior style التصميم الخارجي للهاوس والفلور بلان يعني عدد الطوابق في البيت.
Okay.
So they are developing
houses, homes here, and they are. I'm trying to see how many options does the buyer have. Okay.
We have two ways to do the homes.
مش
First,
6
the exterior
لا 7
it can be thunder, colonial, so it is 8 to 7 colonial and traditional.
Here's the one that we use here again here. فما راح يكون 6
راح يكون عندنا 7 options for this one.
Okay.
So 4 options for the exterior style. All this good. Ranch, 2-story or split. So for the 4 options. For the second thing, which is the floor plan,
you can know from the question letters
options. So 4 to 12. So
cannot be alike.
Each I have to choose the
jump out cannot be alike.
Exactly.
So you use letter A, use B. You can use so the options are one more in the last time.
Let me
okay.
Enlarge the slide for you. Have a look at. Have 2 things or 2 steps to follow. Okay, between the exterior style I have. Then I will choose between the type of floors that I have 4 options, followed by 3, multiply 3 using the multiple 2. Well,
one more example. Here. I want you to pay attention to this example.
Okay.
A permutation in general, but we have a condition that is 50.
Okay. In this type can be thunder, rustic, TP, colonial, or traditional style. So we have 4 options.
No restriction at all. خلاص.
That followed by the number of floors in the home that we will build.
Directly it is 50
the number of floors can be in the ranch way. All of those are ways to
so the result is 50 49. It is 2,400. This is in A.
2-story.
I have a condition. To A,
again, ranch.
One person that they call A will say is
so 3 options. Otherwise, he's not serving. So 4 multiply 3 using the multiplication rule. It's equal to.
Will play this game with us.
Will be. Otherwise, he said, I'm not gonna. This multiplication rule can be.
The condition is that A
generalized
only
more than 2
steps.
يعني if I'm 4 things,
I'm gonna choose
the coin 3 times, or I'm not gonna choose times. Again, I don't want to generalize this.
I choose the president.
Operation 2 can be done in 2 ways. In 3 ways. Import till we reach in K, then in 1K the times that we have. Okay, we have the following example. Let me enlarge. Will be with me in the game if he's a president.
Sam is going
and
to assemble
other option A will not play choices of
okay.
So
if
A play with me, I will remain with 49 to choose the treasure
hardware from
where.
Okay.
So all are 49
the memory
now. He can choose from 3. So multiply with
the president
3 عندي 49
bundle from 5 local
in
stores.
case
So multiply
the first case I have
5.
49.
How many ways can Sam order bar?
Then it is 2 multiply 4 multiply. So he has a 120 ways to choose the parts of his computer. Okay. This is the multiplication rule. You do the operation 1, operation 2 in N2, operation 3 in N3. So then you multiply everything to get the overall or the total of the weight that you have. Okay,
Play with me.
clear? In the second option I have 2359. whether we مش successive مو أشياء ورا بعض. It is options. So we add actually the 49 with the 2359. The result will be 2401 weight in all. Okay. Now, in the second case, we have the following. Suppose that a computer assist
A multiple choice question now. We have a computer test that has 5 questions in it. Okay, so I have a 5 questions. So 1, 2, 3, 4, and 5.
2 people.
5 questions we have.
So
the computer verbal question for the 5 option for the first question, and 8
so if I choose
for the second question, and 6 for the fourth, and 10 for the fifth. How many different 5 question tests
I choose B
can
and
the
C?
computer select? So I have 5 question options for each one question. Of course, it is a multiple 5 multiplied 8.
If I choose them, one integer,
multiply
the other one is
multiply the result
so
here
I
you
will
will
have
get it.
2
It is
options.
12,000.
In case 2, I will cancel
different ways to do
okay,
the
I'm gonna
questions of
cancel them. I remain with how many?
Test. Let's see example here. How many 4 number
48
larger than 7,000 can be formed?
The total is what? 2, 5,
From
6,
the digits 5, 6, 7, 8, 9 without
2, 5, 8 as you can see here. Okay.
repetition, يعني without repeating the things. Now pay attention to this question very well because
بالضبط. Clear? Okay, good.
usually there must be a question similar to this.
We have the following theorem. And the following
We are talking about the number of distinct limitations of n things, of which in one kind, in 2 of second kind, in 3 of the third kind, so I have n thing مقسمة in 1 thing, in 2 thing, in 3 لحدت in k. 4-digit number, so
in 1,
I have
in 2, in 3,
number
and
in k. Is the number of the permutation in this case ايش is factorial in k لحد ما نوصل
4-digit.
it should be larger than 7,000 يعني 7,000 8,000 or 9,000. I'm choosing my digits from 5,
See
6,
this example
7, 8,
we have
and
in the
9.
college.
Okay.
So for the first place, number is larger than 1,000.
And the 10 players to be standing in row. Among 10 players, one freshman, يعني أولاني, then 2 sophomore students.
Okay.
Then 4 juniors, then 3
and I want to get So it'll be
how many different ways can they be arranged in a row if only their class level? I have only 3 numbers to choose in between. Will be distinguished. If I choose my first number, I cannot repeat it because they say no repetitions allowed. I my first number, whatever I choose, and I have 1, 2, 3, 4, 5 numbers already. Already I have 5 numbers here. I have numbers. I ordered them in the so the I have 10 options here. In this case, then I already choose a 1, 3 options. So I remain here.
Is that clear?
Multiplication rule. Everything. 3 for 22 different.
Okay. Do you have any comments? Any questions, students?
Okay.
You have any questions?
Next theorem, the same thing as you can see. شايفين هنا this side it is factorial
into the same rule.
Hello.
عندي I'm put them in one way, in two way, in till we reach in K. I have n things. I'm trying them. I'm trying to put in partition. So same thing, factorial in R where the sum of all the n's should be equal partition.
Now you can hear my voice. Now your voice.
Example, you will get this in the
now is my voice clear now?
How many ways can 7 graduate students غرفة حق 3 أنفار and 2 double.
Okay, I'm gonna repeat it, but now you can hear my voice.
أنا عندي 7 أشخاص 1 room يعني 3 أشخاص في غرفة and 2 double room يعني شخصين. So 2
the 2 examples so my voice
factorial 7 and
factorial 3 clear?
factorial 2 factorial 2 the 110 واضحة؟ واضحة؟ done with the permutation ننتقل للcombination اللي هي ال NCR. Again, this is something you can put in the calculator. Now in state of the ways, but what order is not important. يعني the same thing. I'm choosing something out of something, but with order not important. Huh? Suppose that an art museum has 8 paintings by a given artist and art museum. So 3 out of this I have A are borrowing it. 3 out of them. Now why I say combination here not permutation لأن الأوردر أنا لو حطيت بين 2 بين 1 في فرق؟ No البنت يعني لوح هنا قطع فنية. So أنا لو اخترت 1 2 3 أو 3 2 1 it's all the same. We choose the combination here. The rule of the combination this is n above r. It is factorial n على factorial r factorial n minus r. So it's equal to factorial n factorial r factorial minus t. Okay, so 8 out of 3 out of 8, this is the rule. You will get it is equal to 50. Clear? Okay, example now. How many can we choose a chairperson?
Okay, good.
Vice chairperson. How we are choosing? كم واحد قاعد أختار؟ قاعد أختار 3
here I think
out of 10. الأوردر ولا لا؟ مهم ولا لا؟ So let's go back. الأوردر important. So again, we have الأوردر important.
have computer assisted test.
Yes, it is
I have a test.
test.
In this test, I have a question. 5
filtering.
places to fill. The computer stores 5
in A راح نحلها بالpermutation.
comparable question for the first questions here. A second and 6 for the third, 5 for the fourth, and 10 the fifth. How many
now in how
many different 5 question tests can the computer
أنا الحين بختار
one or more questions? So
just of 3 people out of 10.
we have the multiplication rule in this time. We multiply,
not important, you know.
The result is
Order important or not important?
12,000.
No, it's not important in this case. So I'm using what? The combination. So it's not important. So I'm using the combination 10, 3. It's fine. I'm gonna repeat it. It's fine. The result will be 120. شايفين الفرق ما بين how many 4 digit numbers now larger than 7,000 can be formed from the digits 5, 6, 7 and 8 and 9. كنت بختار pay attention to this one. I want 4 digit numbers and without repetition, and we cannot beat the numbers that we choose. With the digits 6, 7, 8 and 9, and my choice should be a number greater than 7. I'm talking about a number, so 4 places fell here. ماشي? My number should be greater than 7,000. Greater than 7,000, يعني it could be 7 something, 8,000 or 9,000. It cannot be 5 or 6,000. 10. How many choices I have for the first place? I have 3 choices. So he has 5 Game Boy cartridge from his collection. 10 of them are arcade. Here I have already 1, 2, 3, 4, 5 choices. صح ولا لا? I have 4. How many ways are there that one of them in the first place you remain with choices for the third place, so عندنا one of them you remain with the 3 choices, for the fourth place you remain with 2 choices. Now the multiplication rule said multiply everything, multiply 3, multiply 2, which so is 72 we can say different ways. 5 C3 have to form 4 digit numbers that we have, and she's choosing a 3. So it is that clear? 3, which is 120 here. And for the sport, he has a 5. She's choosing a 2. Depends on the options. 5 options I have here. 5. Let me show you a simple example. 10. Now it is a successive process here. So one thing another after the other thing. So we multiply, actually multiplication rule, 120 with the 10. The result is 1,200. Depends on what they are writing. They should write for you. You will see an example. Don't worry. When repetition is allowed. If repetition is allowed, it's fine to repeat the number. Let me give many. Of course the arrangement is not important. هي قاعدة تختار لألعاب هنا لعبة games صح ولا لا؟ So مش مهم عندي الترتيب. Finish for today. I want your attendance, please. Write me your attendance. I'm gonna check it. 1, 2, 3. In A, have the list here. And I want you to write repetition 110 and allowed 120. Repetition Abdullah, you are from Dammam. Zahir from Dammam. Can you? If repetition is allowed, I want to form 4 digit number. So I have 4. I have how many numbers? 5. So I can use 5. 5. Abdullah Zahir, I took your attendance. Yeah, I know numbers are from Dammam. I'm done. So it is 5. Gamar, I'm done with you. Malak. 4 times. Okay,
ملك
so the
مصري.
result is 5 to the power 4 equal to 625. Wait, if they are allowing me
معتصم
4, not 5. I have 5 numbers to choose in between.
From
Okay.
Dammam, this letter M. Who's this letter M? Write me your
If
name.
repetition is not allowed, I have places numbers. The first time I have 4 options, 5 options.
I got your attendance. Nuha. I got you.
With a number, I cannot use it again. It will be 4. Then 3, then it will 2. Okay.
Hasna. I got your name.
Let me give you one more example.
Rola.
Example.
Huda. Done.
In how
Muhammad
ways you
Sahar
do or from letters B and C where adjacent
What do you mean, Ahmed? From Dammam lecture is not in Sunday. Yeah, it's in Thursday. If you are from Dammam, your lecture is in yeah, your lecture is okay. Check this. In how many ways we can do a word from the letters A, B, C, D where repetition is not allowed. يعني a password we say. A password, huh? I'm not repeating the letters here. I have A, B, C, D, so I have 4 places. So the first place I have 4 choices. The second place I have multiply 2, multiply 1. Is it clear now? The idea is clear for you? Let's proceed now. 4, 3 multiply 2. Now let's start a new topic. Now we will talk about the permutation and the combination. Our next thing is the permutation and the combination. Okay, good. Now the permutation, or what we call the MPR, the MPR means the arrangement of all or part of set of an object. Now if I have MPR, the permutation can be the ways we can arrange n things
things out of those n things. Okay, so the NPR, the arrangement of r things out. Let's get n, p, and c. I want to arrange them. I want the notations out of those letters A, B, C. We can write it as A, B, C, A, C, B, B, A, C, or B, C, A, or C, B, C, A, B, or C, B, A. So six ways to arrange. So I'm talking about 3 letters. Doing a permutation of the 3 factorial. This is a 3 multiply 2 multiply 1. In previous example, I have 3 letters to arrange the 3 letters in 3 places. So it's a 3 multiply 2 multiply 1. صح ولا لا? So this is what we call a permutation of 3 things in 3 places. عندي 3 things, I want to put them in 3 places. Group 3 which is 3 في 2 في 1 like the brief. Now this is the factorial اللي هو المضروب, and this is something reach 3 في 1. يعني for example factorial 4, it is 4 في 3 في 2 في 1. If I say factorial 5, it is 5 في 4 في 3 في 2 في 1. If I it's 100 في 9 في 1, and so on. Will calculator can find for you. And as a special case عندنا الفactorial is 0. The number of permutation of n object اللي هو ال n p n. برتب أشياء n من الأشياء في n من الأماكن. It is factorial n. Factorial 4 is 24. The permutation of the letters A, B, C, and D, and the number of letters A, D, factorial 4, which is 24, which is 4 في 3 في 2 في 1. Okay, so you know that the NPN, the permutation of n things is, yeah, factorial 1 is 1. That's correct. Now I know is NPN is equal to factorial n, and this is how we put 4 things in 4 places. عندي 4 أشياء بحطها في 4 أماكن. طيب, what if I have 4 things and I want to put just 2 places? أنا عندي 4 things. I can do a word with 2 letters only. يعني I have 4 2 places. So 4 is 4 multiply 2 multiply 1, لكن بعد لأن بتسوي places. So it is 4 multiply 3, which is the options that we have. And the rule is the n permutation are factorial n minus r. Let me write this rule here. So MPR, when I have n places, it is factorial n divided by factorial n minus the r. Let me go back to this slide with the examples that we have. In this example 1, we have a license plate that using followed by 3 digits. Okay, 3 letters, they didn't specify 3 letters from alphabet, so I have 26
letters here. Okay, 3 digits from 0 to 9. 0 1 2 3 4 5 6 7 8 9. digit يعني رقم. عندي the numbers from 0 to 9. عندي 10 she's to show. Okay, different blades are possible if I repetition is allowed. Double I repetition allowed. For I, if I'm allowing a repetition, قاعدة أتكلم عن 3 letters followed by 3 digits. صح ولا لا؟ 3 letters followed by, if I'm repeating here, 26 here, 26 and 10 10. ما عندي أي إشكالية. So the result is 26 26 26 10 10 and so the answer is this if you do all the multiplication. Now there's of now repetition is not allowed. The first place I will choose the 26. Okay, the second so 25. The third place list 1 24. Multiply with, it is 9. Do the multiplication as you can see here. This will give you the answer that you want. Is it clear? Is that clear? كيف جات لي 26؟ قال لي 3 letters. طيب أنا إيش الليترز اللي عندي in general؟ عندي الألفابت اللي هي ال A B C 2 عندي 3 digits. They didn't specify the digits, so I have how many digits? I have 0 digit. 1 2 3 4 لحد ال 9. بعد الأرقام الباقية كلها جاية أساسا من ال 10 digits هذه. So digits 10. Okay. Down 2 now. How many different arrangements are drive? The letters of the word drive. How many letters I have? 1 3 4. So I want to do the arrangement. Yeah, the 3 letters are different, so the way so it is factorial 5. That's correct. How many 6 now 6 digits can be formed using the digits 4 5 6 7 8 and 9? How many of them I have? I have 6 numbers here. So this is the option 6p6, which is factorial 6. Correct. Let's do this example. In 1 year, 3 awards: research, teaching, and service. Now, one important thing I want to add for the permutation, that the order is important. إيش يعني the order is important؟ يعني when I say like A B نفسها C B A، صح ولا لا؟ البرميتيشن I'm trying to change the places هنا. So the permutation. This is very important. That the order is important for the permutation. And let me write it.
example here. Teaching and service will be given to a class of 25 graduate students. So how many awards I have? 3 of them. The order is important now. Yes, the order is important. The prize will go to research, the second for the teaching, the third for the service. So I have 25 students and I'm choosing between them to give the 3 prizes, and the order is important here, okay, because the first is the service permutation 3. Again, this permutation you can find it in the calculator, students, you can find this in, so you can find it with this one. Your calculator, you can get that at a 25 permutation 3 is equal to 3 and 800. Okay, one more example. Now a serial number for a product are to be made using 2 letters followed by 3 numbers. So I'm using 2 letters here, follow that with 3 numbers. If letters are to be taken from the first 8 letters, so I have 8 letters using 2. صح ولا صح؟ And with no repeat, and the number order is important طبعا لأن هنا, and then a number to be taken from the digits 10 digits اللي هي من 0 to 9. So عندي 10 digits, 3 digits them. That's correct. 2 of happened after the other one, يعني we do the multiplication rule in between. So you find AP2 MP3. يا صح 10 في 98 صحيح. It is 10 في 98, which is 720 for the digits, and for the letter 2 by 7, which is 56. Multiply the two things together, this will be about 40,308. Is it clear? Good. Good to hear that. One more example. Many 3-letter code words are possible using the first 8 letters of alphabet. Doing a code of 3 letters, okay? Letters of the alphabet, but I have A, B, and C. If no letter can be repeated, if it means I have 8, then I will use 7, then I will use 6. So it is 8P3 actually, 8 for 7 for 6, which is 336. صح. Repeat it. 8 and an 8 and an 8, correct, the 10. Now in C, adjacent letters cannot be alike. Adjacent letters يعني adjacent يعني جنب بعض cannot be alike. So الفعل بعدين بيكون عندي 7. اللي بعدها how many؟ مش 6 لا 7. I use again. So it is 8 for 7 for 7. Use the one that we use here again here. فما راح يكون 6, راح يكون عندنا 7 options for this one. Okay? Clear? Good. You can know from the question letters cannot be alike. اللي جنب بعض cannot be alike. So you use letter, you use B, you can use. So the options are one more in the last time. Okay. One more example here. I want you to pay attention to this example. A permutation in general, but we have a condition that is 50 TP2 if no restriction at all خلاص directly it is 50 permutation 2 أنا عندي 50 يعني اللي هو رئيس وأمين سر. So the result is 50 في 49 it is 2400. This is in A. In B I have a condition. A, one person that they call A will say he is a president, otherwise he's not serving. يعني في شخص اسمه A will play this game with us, will be president, otherwise he said I'm not gonna play. Okay, the condition is that A serve only if he's a president. Two options. إما I'm gonna choose the president, or I'm not gonna choose him. I don't want him to play with me. I choose the president. Okay. When 40 will be with me in the game if he's a president, and other option A will not play at all. Okay, if A play with me I will remain with 49 to choose the treasurer out of them. Okay, so all are 49 now. أنا الA اخترت president يبقى عندي 49 بختار منهم واحد يعني عندي 4. So in case A, in the first case I have 49 ways. Okay. Play with me. In the second option I have 2359. Whether we مش successive مو أشياء ورا بعض. It is options. So we add actually the 49 with the 2359. The result will be 2401 ways in all. Okay. Now, in the second case, two people or not at all. So I have Nancy قالوا لي إما إنه we serve together or we will not play at all. Okay. So if I choose them, If I choose B and C, and if I choose them, one is treasurer, the other one is the president, so I will have two options. In case 2, I will cancel BC. خلاص ما أبغاهم يلعبون. Okay, I'm gonna cancel them. I remain with how many? 48. وال 48 برجع اختارهم B2 2256. The total is what? 2256. 2, and the result is 2258, as you can see here. Okay. بالضبط. Clear? Okay, good. We have the following theorem, and the following we are talking about the number of distinct permutations of n things, of which in one kind, in 2 of second kind, in 3 of the third kind, so I have n things مقسمة in one thing, in two thing, in 3 لحدت in k. in 1 و in 2 in 3 and in k. Is the number of the permutation in this case? It is factorial in k لحد ما نوصل. Let's see this example we have in the college. And the 10 players to be standing in row. Among 10 players, 1 freshman, يعني أولاني, then 2 sophomore students, then 4 juniors, then 3 seniors. How many different ways can they be arranged in a row if only their class level will be distinguished? So عندنا partition factorial 10 على 1 factorial 2 factorial 4 factorial 3. The result is 12,600. So هذا a special case of a permutation. In this case we use this theorem here. Clear? Is that clear? Okay, next theorem, the same thing as you can see. شايفين هنا this side it is factorial into the same rule. عندي something put them in one way, in two way, in till we reach in k. I have n things, I'm trying them, trying to put them in partition. So same thing, factorial in R, where the sum of all the n's should be equal. Partition تجزئ لازم مجموعهم equal to n. Example, you will get this in the example. In how many ways can 7 graduate students غرفة حق 3 أنفار and 2 double room, أنا عندي 7 أشخاص في 1 triple room يعني 3 أشخاص في غرفة and 2 double room يعني شخصين so it's 2 so it is factorial 7 على factorial 3 factorial 2 factorial 2 the 110 واضحة؟ واضحة؟ done with the permutation ننتقل للcombination اللي هي ال NCR. Again, this is something you can put in the calculator. Now, in this case, number of the ways, but what order is not important. يعني the same thing. I'm choosing something out of something, but with order not important. Huh? Suppose that an art museum has 8 paintings by a given artist and art museum. 3 out of this I have A are borrowing 3 out of them. Now why I say combination here not permutation لأن الأوردر أنا لو حران بين 2 بين 1 في فرق؟ No different. البينت يعني لوح هنا قطع فنية. So أنا لو اخترت 1 2 3 أو 3 2 1 it's all the same. We choose the combination here. The rule of the combination this is n above r. It is factorial n على factorial r factorial n minus r. So it's equal to factorial n factorial r factorial n minus t. Okay. So 8 out of 3 out of 8, this is the rule. You will get it is equal to 50. Clear? Example now. How many can we choose a chairperson, vice chairperson? How we are choosing? كم واحد قاعد أختار؟ قاعد أختار 3 out of 10. الأوردر ولا لا؟ مهم ولا لا؟ الأوردر important. Again فكروا فيها. الأوردر important إلا important. Yes it is important. واحد chairperson والثالث النائب والسكرتري فأكيد الأوردر important هنا. So in A راح نحلها بالpermutation. It is 10 شايفين؟ say it is 10p3 and the result is 10 في 9 في 8 it's equal to 720 per. Now in how many ways can we choose a subcommittee of 3 people? أنا الحين بختار committee اللي هي لجنة just of 3 people out of 10. Again أنا عندي 10 بختار منهم 3 بس الأوردر not important هنا. Order important or not important? No, it's not important in this case. So I'm using what? The combination. So it's not important. So I'm using the combination 10 3. The result will be 120. شايفين الفرق ما بين؟ وأنا عندي 10 بختار منهم 3. المرة الأولانية كان في لهم مناصب فكان الأوردر is important. المرة الثانية كنت بختار مجموعة من ثلاثة. So الأوردر is not important. Okay. We have the cartridge is a collection of 10 arcade and 5 sport games. So he has 5 Game Boy cartridge from his collection. 10 of them are arcade, 5 are sport. How many ways are there that his mother can get him 3 arcade and 2 sport games? So عندنا 10 arcade وبختار منهم 3. This is the 2 games. So we can say it is 5C3. No, it's not 5. It is a 10 arcade and she's choosing a 3. So it is 10-3, which is 120 here. And for the sport, he has a 5. She's choosing a 2. So it's gonna be 5C2. 5-2, which is a 10. Now it is a successive process here. So one thing happened after the other thing. So we multiply, actually the multiplication rule, 120 with the 10. The result is 1,200 ways that we have. Of course the arrangement is not important. هي قاعدة تختار لألعاب هنا لعبة games صح ولا لا؟ So مش مهم عندي الترتيب. Finish for today. I want your attendance, please. Write me your attendance. I'm gonna check it. I have the list here, and I want you to write me your attendance. 110 and 120. Abdullah, you are from Dammam. Abdullah Zair from Dammam. I took your attendance. Damar. Abdullah Zair, I took your attendance. Yeah, I noticed you are from Dammam. I'm done. Damar, I'm done with you. Malak. Malak Masri. Mu'tasim. Mu'tasim also from Dammam. This letter M. Who's this letter M? Write me your name. How can I know? Madeline. I got your attendance. Nuha. I got you. Hasna. I got your name. Rola. Huda. Done. Muhammad Sahar.